In this video, we'll do our final example of the day for practice equilibrium questions and calculations. This time, we're going to do a little bit of prediction, try to predict the optimal conditions for temperature and pressure for a particular chemical reaction to make the most product. And as before, pause the video, see if you can answer the questions, and then we'll come back and discuss the problem solution. So, let's talk about the conversion of ethylene to ethane. So, we have a chemical reaction that takes ethylene, C2H4, and converts it to ethane. Now, they've told us a couple of things about this reaction. First off, it's a gas phase reaction. We got a bunch of G's here. Second off, delta H is less than 0. So, delta H less than 0 means this reaction is exothermic. That will help us probably predict the temperature profile here. So we've got an exothermic chemical reaction to deal with. Well, it doesn't matter what order we do these, but the problem specifies temperature and pressure, so let's just do temperature first. So since the enthalpy change is less than 0, the reaction is exothermic. And one way you can think of an exothermic reaction is an exothermic reaction is kind of like a reaction that has heat as a product. So you can think of the reaction as something like this: C2H4 plus H2 goes to C2H6 plus heat. Now, heat's technically not a product, but for purposes of using Le Chatelier's principle, which is what this is all about, we can use heat as a product here. Now, temperature. Will a high or low temperature make more ethane, or C2H6? So let's think about what would happen. If I were to lower the temperature, what would I be doing? I would be removing heat. So if I removed heat, then the reaction should shift to make more of it, which means the reaction would shift to the right at a lower temperature. If I were to add heat, run the reaction at a higher temperature, the reaction should shift away from the heat and move to the left. Now, to the left is the reactant direction. So the way this is going to look is we're trying to make more ethane. So if we run at lower temperatures, the equilibrium should shift to the right for more ethane, which is what we actually want. So lower temperatures looks like a good condition here, because higher temperatures have the opposite effect. So remember, this stuff here is our ethane. So lower heat shifts the reaction towards the heat, which is the ethane side. So it looks like low temperatures are what we kind of want to run at here. How about pressure? Is this equilibrium affected by pressure? Probably a good question to answer at first. For an equilibrium to be affected by pressure, you have to have a different number of moles of gas on each side of the equilibrium. If we look here, C2H4 gas, that's 1 mole of gas on the left, H2 gas, that's 2 moles on the left, so 2 moles of gas over here, and that's going to go to C2H6, or ethane, which on the right hand side means we only have 1 mole of gas. So this is a reaction where the number of moles of gas is different on each side, therefore it will be affected by equilibrium. It will be affected by pressure. So different number of moles of gas on each side so pressure affects this equilibrium. Now what's the effect going to be? So if I run at higher pressures, if I compress this, then the equilibrium is going to try to reduce that pressure if it can. So if I run reaction at high pressure, then the equilibrium will shift to the side of the reaction with fewer moles of gas. Now that side would be the ethane side. So if we want more ethane, we want to run at a lower pressure. If we ran at a high pressure, it would shift. Excuse me, we want to run the reaction at high pressure. If we ran at low pressure, it would shift the reaction in the other direction. So if you lower the pressure, the reaction is going to try to make more gas, which would go to the left, which is not what we want. So our optimal conditions would be low temperature, at least if you're talking about conversion, and high pressure. Now, you might not want to run at absolute zero or close to it because you would lower the reaction rates so low that you wouldn't get any product. But within reason, the lower the temperature and the higher the pressure, the more ethane you will actually get. So this is an example of using the Chatelier's principle to try to predict the best conditions to run a reaction. And that's it for this example. Thanks for watching.